Start.
Good morning, everyone. I hope so. Everyone is fine, having good health. In the last session, children, we have learned about the types of motion. Then we have learned about the simple pendulum and second pendulum and how to find out the time period by using the pendulum. In the today's session, we will learn about the distance, displacement. We will learn about the speed, velocity, uniform motion, and non-uniform motion. So then, distance and displacement, children. What is distance here? So distance is nothing but you can see a dotted path. Dotted path is called as a distance. Okay. So we can say that distance is defined as the actual length of the path covered by the moving object. So actual length of the path covered by the moving object is called distance. Okay. And then you can see the displacement also. So what is displacement here? So displacement is the separation between A and B. So separation between A and B is called as a displacement. So separation between the initial position and the final position of the object is called as a displacement. So look at here. Look at this figure. A body is traveling from A to B. Okay. So here the distance is also x and displacement is also x. Okay. And look at the second figure. A body is traveling from A to B and then B to C. So as the body is traveling from A to B and B to C, then the distance covered by the body is 4 meter plus 3 meter. It is equal to 7 meter. And the distance is 4 meter plus 3 meter. It becomes as a 7 meter. But the displacement is just the separation between the initial and the final position, which is equal to 5 meter. So here, children, distance is 7 meter and displacement is just 5 meter. Look at this third figure. A body is traveling from A to P, P to Q, Q to R and R to C. So here, children, as the body is traveling from A to P, P to Q, Q to R and R to C. So here displacement is still 5 meter as it is the separation between the initial and the final position. Now the difference between the distance and the displacement, three things should be very clear to you. One is that as the body is moving from one point to other point, okay, along a different path. You can see in this figure the body is traveling from one point to other point along a different path. Here also you can see the body is traveling from one point to other point along a different path. So children, in both the cases, displacement is same, which is 5 meter. Here also displacement is same, which is 5 meter. Second thing, children, as the body starts from initial position and if it returns back to same point, okay, then we can say displacement is 0. As the body starts from A, after traveling certain distance, if it cover back again to the same position A, so in that case displacement is 0. And third one, as the displacement is the measured from initial position to final position, so displacement has direction. Okay, it is a vector quantity. On the other side, children, distance is not measured along a particular direction. So distance is not measured along a particular direction. So it has only magnitude but no direction. So we can say it is a scalar quantity. Learning about the distance and displacement, let us learn about the speed and velocity difference. What is the difference between speed and velocity? So speed is defined as distance upon time. Speed is defined as distance upon time and velocity is defined as displacement upon time. So look at this, children. Speed is defined as distance upon time and velocity is defined as displacement upon time. So let us define speed first. Let us learn about the speed first. So speed is defined as rate of change of distance. Speed is defined as rate of change of distance and it is a scalar quantity. As what is the meaning of rate here? The term rate means per unit time. Per unit time. So look at the children. Look at this figure here. AB is a straight line. Okay. AB is a straight line. Children, AB is a fixed line. Okay. And on a line, fixed line, there is a point O. which is a fixed point, okay, and a box is moving on a straight line from point P to point Q, okay. So the distance of the OP is x1 and distance from O to Q is x2. So the change in the distance from the point O, which is equal to x2 minus x1. So that gives you the change in the distance, okay. So then we can say the speed is equal to x2 minus x1 divided by t. As you know very well, speed is the rate of change of distance. So x2 minus x1 equal to x upon t. So as per definition, speed is defined as distance covered by the body upon time taken to cover the distance. So then children, distance covered is equal to speed into time. The distance covered equal to speed into time, because when speed is equal to distance upon time, then distance covered is equal to speed into time. Or you can say time taken will be equal to distance covered upon speed. Okay. Now what is the unit of distance? What is unit of speed now? The speed in SI unit, it is measured as meter per second. The speed is measured in meter per second. And you can also learn that speed of the vehicle is usually expressed in terms of kilometer per hour. So conversion now, 1 kilometer per hour equal to how many meter per second? So let us do the conversion. 1 kilometer per hour means 1 kilometer means 1000 meters and 1 hour equals to 3600 seconds. By cancellation, we learn that 1 kilometer per hour equals to 1 upon 3.6 meter per second. Or you can also write it as 1 meter per second equal to 3.6 kilometer per hour. Okay. After speed, let us learn about the velocity. Okay. Velocity is defined as rate of change of displacement, and velocity is given as displacement of the body divided by time of travel from initial to final position. So children, displacement is a vector quantity because it has magnitude as well as direction. So velocity is also a vector quantity, okay, compared to scalar. Okay, speed is a scalar quantity and velocity is a vector quantity. Now what is the SI unit of velocity? So SI unit of velocity is just same as speed, which is equal to meter per second. Let us recapitulate about what we have learned so far. So today we have learned about the distance and displacement. What is distance here? The distance is the actual length of the path covered by the body is called as a distance, and displacement is nothing but the separation between the initial and the final position. Okay. Then we have learned about the speed. Speed is defined as rate of change of distance. It is a scalar quantity which is having only magnitude but no direction, and the unit of SI unit of speed is meter per second. Okay. Then we have learned about the velocity. Velocity is defined as the rate of change of displacement, which is having a magnitude as well as direction. So it is a vector quantity. Okay. And I hope so you got clear with this. So thank you. Have a nice day. God bless you all.